So basically page 413 or so. So what we're going to do is solve equations using a substitution method to start with. Okay. So just to refer us back to what we were doing yesterday, so we've got 2x equals 1/5 of 9 minus 8x. Okay. How many equations do we have? Cameron? Okay. Why did you say 2? Okay, so we could split this into 2. How many do we actually have at the moment? 1. We have one equation with one variable. That variable is x. Right? So we have one method of solving this, but we did say there was another method which was split it into 2 equations in 2 variables. Okay? And that sort of, we had that discussion that if I did this, they're both straight lines, aren't they? So I'd have a situation where we have 2 lines and they're going to cross. And that point is when they share the x and the y coordinate, yeah? So we said that the x value we found is shared, but also we can say that the y coordinate is the same in both. So y equals y. The x is the same and the y is the same. Okay? We can solve it like this, or would you like to go through the process just quickly? Shall we? What would you do first? Aidan? Okay, we can. No problem with expanding the brackets. Apart from, it's what's a 5th times something the same as? Divided by 5. Is that an easy thing to do? Okay, 9 divided by 5 doesn't work. 8 divided by 5 doesn't work. All right? So instead of that, we can write another equivalent equation, which would be, if we multiply both sides by 5, so if I do 2x, multiply that side by 5, and I do a 5th of that, but then multiply that by 5, well, the divide by 5 and the multiply by 5 cancel each other out, and I'm left with 10x's equals 9 minus 8x. Okay? So that's my equivalent. So again, like I've said before, that is now a new equation, right? It's not the same equation, it's a new equation, but it has the same solution. So if we solve this one, I get the same solution as that one. All right? What do I do next? And
add 8x.
So we can add 8x to both sides. 10x plus 8x is equal to 9 minus 8x. Add 8. Just as a side note, guys, as we move forward, you don't have to write everything out that I'm writing out. All right? You can.
We don't need to write the minus 8x plus 8x.
No. But in fact, this is probably the first time I've ever I write it. When I do it myself, I tend. You've probably seen me sneak it in there, haven't you? I just write, I'm going to add 8x.
Yeah.
I just do it like that.
Yeah.
All right. So that's normally what I would do. Just at the moment, I'm writing to show you the equivalent transformation thing. So we then end up with 18x equals 9. And then, sorry.
And then divide by 18, so you get x equals 0.
Yeah. So I'm going to have to stand there. So then you divide by 18, and of course this is where the common mistake comes from. If we divide both sides by 18, if I write out that, I'm all good. My answer is 1x equals 2. Huh? But you wouldn't believe how many times I see that. It's not 2, it's
0.5.
1/2. Yeah, we simplify 9 divided by 18 to get 1. All right. So what that would mean in terms of my graphs is this line going down here, going through that point, would mean that x is a half. All right, so that's what I was asking you to do. Now, the substitution method is just another way of finding the same thing, but thinking about it slightly differently. But let's take the example that's in example 1. Right, I'm on the wrong page now. So example 2, and it's saying that we've now got 7x plus 2y is equal to 19, and we've got x minus y is equal to 4. So what is the change in the question that has led to us to adapt our approach? Yeah.
We don't have a isolated variable.
We don't have an isolated variable at the moment. Yeah. Before, we could say y equals y and the other side equals the other side, right? But we've got equations that... Do you remember what this form is called? I remember we did a lot of this in 2. This is called what form? Because it's not the gradient intercept form, it's point slope form, it's standard form, yeah? So this is what we quite often see. So what we're going to do, we're going to use a substitution method because we've got it in this form, right? We could do some rearranging and write it the way we've just been doing it before, but actually we don't need to. So I'm going to pick on this side and I'm going to make x the subject. Okay, do you know what that means?
The one that you can solve for.
I'm going to make it x equals. All right, and how do I do that? I'm going to write an equivalent form that says x equals. So I'm going to add the y. I'm going to do it this way this time. So add y. So I end up with x equals 4 plus y. Okay. Now, what do we know about the two equations if I'm solving what's called a system of equations? That x equals x and y equals y. So anything I can be... Anything that's equal anything I can replace. Yep.
Now you can put that equation into your first one.
Yes. Sorry, I don't know what that happened. Yes, I can. I can replace. Yeah. So this value here, right? This x is the same as that x, and I can actually replace that x with this instead. All right, so I'm going to put little brackets around my x, and I'm going to put little brackets around my 4 plus y. Up to you if you decide to do this or not. But we then have, this one now becomes, instead of 7 x's, it becomes 7 lots of 4 plus y. Plus another 2 y's is equal to 19. Now, the only reason I'm allowed to do that is because I know that the x's and the y's are the same at a particular point for these two lines. Will this method at this point ever not be applicable? Will I ever not be able to do it? Well, I've just said it's only viable if the x and y values are the same at a particular point. Therefore, if the lines don't actually ever cross, they never share an x and a y point, do they? So this method, just like any other method, would not work because they have to share an x and a y, and if they don't, we can't do it. But we'll come across that in a bit. Anyway, what do we do from this point? I've got to sit down. So now we've got a variable, one variable equation in y, so we can just do, what would you do now to solve for y? Expand the brackets, so we end up with, okay, plus 2y's equals 19. And then we've got 28 plus 9y equals... Right, let me ask you this. Is this an equivalent form to this? Or an equivalent transformation, should I say?
No,
It's what?
it's the same.
It's the same, good. It's just in a different form. It's been simplified. It's not a transformation. It's the same thing. All right, I've just simplified at that stage. All right, if I put that into my graph, I would end up with exactly the same line, not a transformed line. What do we do now? Subtract the 28. You'll see how I'm going into my shortcuts now for writing it down, but up to you. You develop your method that you want. And we end up with 9y equals 19 minus 28 is 9? Negative 9? And then divide by 9, and we get y equals negative 1. Now what do we do? Yeah, which one, or doesn't it matter?
It doesn't matter which is the simplest one.
Yeah, and which one's the simplest one? One where we said x equals now. I'd use that one. All right, so I now have, I know that, y equals negative 1, so x equals 4 plus negative 1, which is 3. Yeah. So x is 3, y is negative 4. There you go, done. Let me just ask you to do something though. All right, I'm not going to do it, but before I let you loose on the rest, because any questions with that? It's fine, isn't it? Same understanding, same principle. But what I want you to do is this. So you probably know what's going to happen. I want you to rearrange this into this and then plug this back into that and tell me what you get. Just go through the process. So what we did was rearranged equation 2 and plugged it into equation number 1. Right? That got transferred over here, substituted in. But what happens if you rearrange 2 and then plug it into 2? What do you get? That's what I'm after. Yeah, if you just to go through it like you've already done, right? If I substitute that into there instead, I end up with 4 plus y minus y equals 4 plus y, okay? And you end up with then...
Was the plus y was your... Plus y,
yeah, sorry,
what was your working out?
Yes,
It's equal to 4.
you're right. I was just equal 4. So then that ends up with being 4 equals 4, which, like I say, it's not a lie. Nothing wrong with that. That is perfectly correct. It just doesn't get me where I want it to be. All right. So the reason why I go through that is because that, again, happens in the heat of an assessment if we're not laying things out. Now, you'll notice I only did it towards the end there, but I've labelled my 2 equations 1 and 2, right, to keep them separate so I know where I'm working. People that don't get lost and can then substitute into the wrong thing. So if you ever end up with a situation where 4 equals 4, hopefully you get 4 is equal to 4. Otherwise, there's a bigger problem. All right, but you might have just substituted back into the same one that you've already rearranged, especially if it's a harder rearrangement. Why did I choose, by the way, to rearrange this one and not the other one? Yeah, so I could do it the other way around, absolutely no problem. It's just harder. This one was easier. I could just go. Why did I choose to make it x equals and not y equals?
Because the
Y is negative, yeah, just again, easier to do that because I need both. Be wary though, not wary as such, but be cognizant of the fact that sometimes you are being asked to solve for x or solve for y, especially if it's like a criterion D question. So if you rearrange and get the x equals, but you actually want to solve for x, and you've replaced x, you just get an extra step or 2 to do. So we're talking efficiency. All right? Any questions, or do you want to just get on with practice 2 on page 413? Yeah?
In this situation, it was pretty obvious that they wanted to use x minus y equals 4 as the
Yeah.
So then it's maybe easier.
Yeah, and to be honest, if we have a situation where both of them are difficult to do to rearrange, we actually have another method. All right, so they all work, but they have their uses at certain times. So it's all good. I think. Well, we've got plenty of time. More than that, 20 minutes till 11. But yeah, have a go. If you're all good with it, if you think it's really easy, then we can move on to the next one, or you can move on to the next, which is the elimination one, if you're ready to do that, which is the next pages.